Welcome to Advanced Problems video. In this video, we are going to solve a high level and advanced level of problems. I hope you enjoy solving those problems. Then let's get started. Here is the first problem. This problem is about the remainder theorem and it's not so hard. So I think we can solve it without any burden. And there is the second problem. It's very interesting to solve. I hope you can enjoy solving it. And here is the last problem in this video, which is very difficult. It's about the remainder theorem. It requires you very deep consideration about the theorem, but please try to solve it for yourself. It's worth it to take your time. I will give you the solutions very soon, but I always recommend you to try to solve those problems for yourself first. That will make watching this video more interesting and helpful. In 7 seconds, the solution part will appear. Here is the first problem. It says that if the polynomial x to the 3 plus ax plus 4 is divided by x minus 1, the remainder is minus 3. The quotient is q of x. Our goal is to figure out q of 2. We can produce this equation from the given condition, right? And putting x equals to 1 into the equation let us know that a is equal to minus 8. Let's move minus 3 from the right-hand side to the left-hand side. Then our equation becomes x to the 3 minus 8x plus 7 equals to x minus 1 times q of x. And the left-hand side can be factorized by x minus 1. So if we use the synthetic division like this, we can get to know it. Therefore, the quotient q of x is equal to x squared plus x minus 7. So q of 2 is just minus 1. This is the solution to this problem. It's not so hard, right? Then let's move to the next question. Here is the second problem. Alpha and beta are the two roots of the equation x squared plus 3x plus 1 equals to 0. Because the two roots are alpha and beta, we can write like this. By comparing the right-hand side and the left-hand side, we can get to know that alpha plus beta is minus 3 and alpha times beta is 1. You will learn the relationship between the two roots and the quadratic equation very soon, but I assume that you haven't learned it yet. Anyway, there are two roots of the equation, so we can also write like this. From here, let's add plus alpha and plus beta on both sides to the two equations. Then, alpha squared plus 4 alpha plus 1 is just alpha, and the beta is also the same, right? So, the expression becomes beta over alpha plus alpha over beta, which is alpha squared plus beta squared over alpha times beta. By the formulas of multiplication, we can find out alpha squared plus beta squared, which is 7. So, the solution to the problem is just 7. This is the solution to this problem. Is everything clear? If everything is clear, then let's move to the last problem of this video. Here is the last problem. It says that if function f of x is divided by x plus 1 to the power of 3, the remainder is x squared minus x plus 1. And 3 is the remainder that f of x divided by x minus 1. Our goal is to find out the remainder that f of x divided by x plus 1 square times x minus 1. What we can get to know from the given condition is that f of 1 is 3 and f of minus 1 is also 3. And the remainder r of x, where we need to find is second order polynomial. If we define r of x as ax squared plus bx plus c, there are 3 unknown values with 2 known conditions. So, in this way, it might be very hard to solve. Here is another idea. What if we can express the remainder r of x in terms of x plus 1 squared? If we add 3x to both sides of the equation, it can be written like this, okay? And this blue line can be factorized as x plus 1 squared. Then the right-hand side can be factorized by x plus 1 squared. So we can get this equation. What we can find here is that this one, minus 3x is the remainder that function f of x divided by x plus 1 squared, right? If we write our remainder r of x as a times x plus 1 squared minus 3x, the function f of x can be written like this. Is it okay? And it also shows that the remainder by x plus 1 squared is minus 3x. So, it is clear that we can write our remainder rx like this. Let's put x equals to 1 into the equation. Then f of 1 is equal to 4a minus 3. And we know that f of 1 is just 3. Finally, we can find the value a, which is 3 over 2. So the remainder r of x is 3 over 2 times x squared plus 3 over 2. This is the solution to the problem. It was quite hard because you have to think the idea that you need to find the remainder when f of x is divided by x plus 1 squared, right? This is everything for this video. I hope you enjoy it. If it was helpful, please click the subscribe button. I wish you always be healthy and I will see you in the next video. Bye bye.